Hi everyone. All right, so we're going to do notes 12. It's all the exponent properties. So we're going to apply exponent properties along with order of operations to simplify expressions. So steps to help you simplify. There's not many. It's all stuff that you have done and should know. So if you have fractions, simplify your fractions as much as possible. Okay, so as like my little abbreviation here, as much as possible before you do anything else, because it just is going to make your life easier. And then you're going to use order of operations along with your exponent properties. Okay, so there's no one right way to do this. The one main advice I can give you is to just simplify your fractions first, and then you can use your properties to move things around and distribute things like that. So we're going to do a quick review. So negative exponents, remember when you have a negative exponent and the base is over 1, you're going to want to move that base along with the exponent so that it can be positive. Okay, again, you're not flipping the fraction, you're only moving what's negative. So if it's negative in the bottom, you are moving it to the top so that it becomes positive. Okay, second one, 0 exponents. So anything being raised to the 0 power, like what we have here, 4 times a, b, c, all in parentheses raised to the 0, is really 4 times 1, because the 0 only is the parentheses. So then you should get 4. So just a quick reminder of what that is. Only what's being raised is what gets simplified with that. Product or quotient of powers. This is where you can add or subtract your exponents. So remember, like bases that are being multiplied, you can add your exponents. Like bases that are being divided, like we have here, you can subtract. So 2 minus 3, that's a to the negative first, and all your powers when you're done need to be positive, so you need to move that guy to the bottom. You shouldn't have any negative exponents anymore. Power of a power is the last one. So power of a power is just distributing your exponent, and everything on the inside gets it. So remember, these all have a exponent of 1. So now we have negative 2 to the second power, m to the second, n to the second. And because this was in parentheses before this negative 2, this does become a positive 4, and then the m squared, n squared. Now, if we also have something like this, I'll try to put it into the bottom of your paper, where we have a quotient. Okay, just like that. This is where you're going to simplify first. So really what we have here is x, 1 minus 2, y, 1 minus 2. These are both going to give you negative exponents. So when you simplify before you distribute, again, it makes your life so much easier. You really have the xy in the bottom, and you still have the exponent outside. You distribute to everything inside. So this now becomes 1 over x squared, y squared. Okay, so that's just a quick review of what we've done. So my recommendation is keep it simple. Okay, keep it simple. Okay, simplify the best you can. Make sure that you are following your order of operations and doing your exponent properties. So keep it simple. All right, so we're going to do some practice. I want to make sure we talk about a few things just to make sure we're on the same page, and then you'll be good to go. So first one is number 1. So we have negative outside the parentheses 9x to the 0. This 9x to the 0 is being raised to the 0 power, or 9x is being raised to the 0 and nothing else. So this is really a 1 on the inside, So then you have a -1 for your answer. Okay, the negative doesn't go away. It's on the outside. It doesn't count. You don't raise that to the 0. Okay. I want to jump to number 2. Okay, jump to number 2. Okay, this y has a power of 1. So when you distribute the exponent into the other exponents, 2 times 4 gives you x to the 8th. Y 1 times 4 gives you 4. Okay, that's your power of a power. Okay. I want to jump down to number 4 now. Okay. Jumping down to number 4. So this one looks crazy complicated, but it's really not. I just want to make sure we do one together just like this. So again, simplify as much as possible. So coefficients are dividing. 4 and 16 have a 4 in common, so 4 divided by 4 is 1. 16 divided by 4 is 4. Okay? So x to the 5th minus 1 is x to the 4th. It's positive, so I'm putting it up top. So this is what we did. We combined it. And then y, 1 minus 4, that gives me a -3. That's going to go in the bottom, so I can make it happy. And then the 3 is going to stay on the outside. So at this point, once you've simplified, oops, there we go. Once we've simplified, we can distribute the exponent into everything. So 1 to the 3rd is just 1. You don't need to write 1. X to the 4th times 3, that gives you a 12. 4 cubed, because this has a power of 1. It's not 4 times 3, okay? That's not what we're doing here. No, no, okay? So 4 times 3, not 4 times 3, 4 cubed is 64. And then y to the 3rd times 3 gives you 9. So if you simplify as much as possible first, it's going to save you a lot of time. Because at some point you're going to have to simplify. It's just a matter of how many numbers you're doing. So at this point, I would like to see you do 3, when it comes up, 3, 5, and 6 all on your own. So go ahead and do that now. All right, so what you should have gotten for 3 is 3x cubed. 6 divided by 2 is 3. 7 minus 4 gives you 3, so you should have an exponent of 3 in here. So then for 5, okay, simplify first. So I end up with x squared over 4 times y to the 4th, still in our parentheses here. Okay, so when you distribute in, remember it's not 4 times 4, it's 4 to the 4th now. Okay, that's what 256 is. So then you multiply your exponents and you should end up with this solution right here. X to the 8th all over 256 times y to the 16th. So for number 6, remember 2 has a exponent of 1. So when you distribute in, you now have 2 to the -2, x to the -6, and now y has a positive exponent. So these are all over 1. You're going to move the negative exponents below. So when you do that, 2 squared is 4, okay, when it becomes positive. So that's where this solution comes from. Okay, so if you have questions, ask me in class. That's what I'm here for. So I did leave 7 and 8. Those are left. So we haven't talked about really combining like terms after we've done our exponent properties, but I think it's really important that we do. So for 7, for example, we have 3 terms. Okay, 1, 2, and 3. Okay, is that a 1? There we go. So each one has something going on with it. 3, I think, is the most simplified. So for each one of these, we're going to do the exponent properties and determine if we can combine like terms. So remember, this 2 has an exponent of 1. You're going to distribute the exponent in. So 2 to the 1st times 2, 2 squared, that's 4. 2 times 2, 4. 2 times 2, 4. So that's kind of nice. Now, a second term, we are going to do the same thing because these all have powers of 1, but remember, this is a negative 1 in front of that x. Okay, it's a negative without a number, which means it's a negative 1. So that also gets, it is a power of 1 right now, so that also gets whatever exponent's being distributed. The only thing that you don't do is you don't multiply by 5, or you don't raise the 5 to the 4, I'm sorry. You don't raise the 5 to the 4th power because it's on the outside. So now, negative 1 to the 4th is just positive 1. We don't have to write that. 1 times 4, we should have x to the 4th, and then we have y to the 4th as well. And then we can rewrite our third term because we don't need to do anything. So looking at our middle term, instead of rewriting the whole problem, 5 times this invisible coefficient of 1 is just 5. So I'm just going to rewrite the problem, or rewrite the middle term, so that it has that 5 in there. Save me some time. Oh, that's 4. Okay, so x4, y4. There we go. So now you need to ask yourself, what like terms do I have? What same variable with the exact same exponents do I have? What same last names do I have? I've got this last name that matches this last name. Okay, those are both like terms. Doesn't matter that the coefficients are the same. The variable and the exponent have to be the same. So these two are the same, therefore they are like terms. So we have 9 of these x4s to the y4s, or x4 y4s that are being added together. We cannot combine this 5x squared y squared because these variables here, while they are both x and y, their exponents are different. So this is in simplest form. So we can put a lovely box around it and say we're done. Okay? So 8 is a little bit less complex, but I want you to go ahead and do that now. All right, so for 8, this is what you should have. Really, you should write it so that the greatest exponent is first, and all the way down, but as long as you have the right numbers, you're okay. So you were doing a lot of adding exponents here because you have like bases and multiplying coefficients. So you should have one of these two. Either one is fine for right now. We'll learn the correct way as we go on. So if you have any questions, let me know. Otherwise, have a great day.